I will explain one of the homework questions from lesson 24 homework and section 9.6. And the example I will be explaining is convert the polar equation to a rectangular equation. So this polar equation has r's and theta, and rectangular equation means we need to only have x and y values. So the simple problem we're going to walk through is r is equal to 12 secant of theta divided by 3 secant of theta plus 1. Now, first thing we're going to do is here, secant of theta is the same thing as 1 over cosine of theta. So in the main equation, we're going to replace all secant of theta by 1 over cos theta and 1 over cos theta. You can handle this math in any way you like, but here is what the book is doing. Once they replace the secant of theta as 1 over cosine of theta, they're now multiplying the top and bottom by cosine of theta to cancel the denominators on each. So when they multiply top and bottom by cosine of theta, this cosine of theta and this one cancels out, and you just get 12 times 1, which is 12. And in the denominator, 3 times 1 over cosine of theta times cosine of theta. Again, the cos thetas will cancel out, and you will just get 3. And 1 times cosine of theta is just cosine of theta. Now, in this equation, now we have r is equal to 12 over 3 plus cosine of theta. Now, we don't want any r or theta in the equation, so we're going to do cross multiplication. When you do cross multiplication, you get 3r plus r times cosine of theta is equal to 12. And if you isolate the 3r by itself, you will get 12 minus r cos theta. And now, if you raise both sides of the equation by power of 2, the reason we want to raise both sides to the power of 2, because if you look at the formulas given under this section, this is the relationship between rectangular coordinate system and polar coordinate system. X is always equal to r times cos theta, y is equal to r times sine of theta, and r squared is equal to x squared plus y squared. So if we square both sides of the equation, 3r squared is just 9r squared. And then this one, I'm just going to write it as 12 minus r cos theta to the power of 2 for now. After this, well, if we continue from here now, instead of r squared, we can write x squared plus y squared. So we're done with the r. We're moving from polar to rectangular from this space. R squared is the same thing as x squared plus y squared, so we can just replace the r squared with the corresponding. Since we have 12 minus r cosine of theta to the power of 2 on the right side, we're going to replace the r cosine of theta by x, because r cos theta is always equal to the x. So that replaces another polar representation to a rectangular representation. So r cos theta will be changing by x. So this is what I got so far, and all r and theta has been cleared out. So we moved from polar coordinate system to the rectangular coordinate system. All we have to do is now organize what we got. So this is what we got. 9 times x squared is 9x squared, 9 times y squared is 9y squared. If you multiply 12 minus x by itself, this is what you're going to get. Now, move everything to the first side and set your equation to a 0. This given polar equation in terms of r and theta is the equivalent rectangular equation to 8x squared plus 9y squared plus 24x minus 144 equals to 0. So when you convert the polar equation to a rectangular equation, you must clear all r's and thetas, and your answer needs to be all in terms of x and y. This is how you solve this question.